My name is Allison Jones, and I'm the Marketing Manager at Rumheld North America. I'll be your moderator for today's webinar. A quick overview of our agenda today. We've got our welcome and speaker introductions, followed by an overview of machining challenges that we're all facing, some basics of quick setup, the benefits of using a quick setup system, application examples, and then we'll move into our Q&A. Several of you provided questions when you signed up, so thank you very much for those. And if you have time and you want to stay on, we do have some new products that we'd love to share with you at the very end. So don't feel like you have to stay, but we would love it so we can kind of show you what we're really excited about. Our speakers today each bring a wealth of knowledge and experience to the field of power work holding. Chris Huseman, our business development manager for power work holding here at Rumheld, is a seasoned professional with a deep understanding of CNC machining and power work holding. His 20-year journey through the industry from machinist to fixture designer has shaped him into an ideal expert to help unravel the pain points of CNC machining. David Vilsack, our engineering product manager here at Rumheld, has been with Rumheld for 17 years and has an extensive background in work holding and assembly. Just a little housekeeping before we get started. We will be recording the webinar and we will email
to completely remove the unit
after today's presentation. If you encounter any technical difficulties during the webinar, please use the chat to let us know. And please use the chat to submit your questions, and then we will address them during the Q&A. So thank you very much, everyone, for being here, and I'll hand this off to Chris.
Thanks, Allison. All right, so thanks everybody for joining today. Go ahead and jump right into this. So today we're going to talk about quick and repeatable setups and how to increase your machining efficiency doing so. As Allison mentioned, myself and David Vilsack are resources here. So in the end, if you have any questions, feel free to ask. First off, a little bit about Rumheld North America. Our headquarters are in Fenton, Missouri, just outside of St. Louis. We work hand in hand with Carlane Manufacturing, who's also in St. Louis, and our products are all manufactured in one of two plants, either in Laubach, Germany, or Rankville, Austria. The product we're speaking about today is all manufactured in Austria. We've been active in the United States since 1982. Rumheld itself has a rich history of over 150 years in the power work holding and machining market. We have over 25,000 innovative solutions in our portfolio, from hydraulic cylinders and work holding elements, high precision quality machine vices, our 0-point systems, which we'll speak about today, as well as many other products, all geared towards manufacturing and machining in general. So, how to increase machining efficiency? So, some of the challenges we face are reducing our setup time. Traditional methods of clamping workpieces often require significant time, including aligning and securing the workpiece. A 0-point clamping system streamlines this process by providing a reference point for quick and accurate positioning, thus reducing setup time. Increasing productivity by minimizing setup times, facilitating rapid workpiece changes and or work holding changes. 0-point clamping can contribute to overall increase in productivity. Enhanced precision and repeatability. Precision and repeatability are critical in machining operations, especially when going from part to part. Our 0-point systems are extremely accurate with a high degree of repeatability. Flexibility in production. With the era of lean machining practices, trying to reduce lead times, etc., every second counts. And having that flexibility to switch from one job to another at a moment's notice and be set up in an accurate way to where you can begin machining immediately is critical in maintaining that flexibility in your production processes. All of this helps to optimize machine utilization by reducing that setup time and keeping your spindle uptime at a maximum. Also, we all face the challenge of reducing. It really makes it by using a precision repeatable system like Zero Point. It helps minimize errors, minimize the amount of parts needed to sacrifice for a setup just to get that first good part. So we'll jump right into what is a 0-point clamping system. In essence, it is a quick change system to accurately locate and secure workpieces and or fixtures on a machine tool table. So Rohmheld Stark is a quick change system that allows you to clamp pallets or parts with accuracy, speed, and flexibility using retention knobs and fast closing clamps. It allows you to connect fixtures to a machine table within seconds with precision. Some of the areas of application include EDM, milling, turning, welding, assembly, automation, additive manufacturing, as well as plastic injection molding, and a host of others. So some of the benefits of a 0-point system are that quick and repeatable setup, drastically reducing setup time up to 90% or more, and going from chip to chip in as little as 60 seconds. A quick little video here just to kind of give you an overview. Sample application case where we're moving from a machine vise. This is one of many options for actuation, just a simple air over oil booster. We've switched to a fixture holding a 3-jaw chuck that is now ready to machine. So among the benefits of a PowerWork or a 0-point system is that increased productivity, allowing you to streamline the manufacturing process, whether through palletizing, direct part clamping, or being able to move a fixture from machine to machine. It's one of many ways we can really streamline that system. Flexibility and adaptability. The modular nature of a 0-point clamping system offers high versatility. They can accommodate various workpieces, shapes, sizes, and orientations, allowing for greater flexibility in machining operations. The system can easily be adapted to different setups, enabling efficient utilization of machine capacities and promoting agile manufacturing processes. Consistent and repeatable clamping force ensures accurate and precise positioning of workpieces, which helps to maintain tight tolerances, allowing you to reduce scrap, allowing you to machine with more aggressive tool paths, because you have that additional stability, which improves your cutting performance, which can lead to better surface finishes, and overall a higher throughput. So you can also achieve enhanced process reliability and flow. You could use 0-point systems at every step of the part. So from the machining to an automated washing, to a quality or a CMM fixture, all the way through to the assembly process. Many of our systems have the options of being either hydraulic or pneumatic. So in some of those secondary processes, you can use a simpler system without ever having to remove the part from the fixture or the retention knobs from the part itself. It can be a very cost-effective system to implement. While the upfront cost can be high, as with any new project cost, the typical ROI for a 0-point system is 6 to 12 months and can be much quicker depending on the existing process. Another benefit of our 0-point systems is they're really tailored for automation integration. So we have the ability to have media couplings directly in the receiver units themselves to transfer hydraulic, pneumatic, or vacuum into an accompanying fixture. We have units with integrated sensing that can provide feedback to the machine or control system that the fixture or part is in the correct position, that the units have clamped, if they've clamped correctly or incorrectly, or if there is no retention knob present. These things are very critical in a lights out manufacturing process or a highly automated production line where there's no direct operator input at every step. We can also integrate these into end of arm tooling pallet changing solutions. And we couple this with our broad portfolio, we can develop or provide really a complete system solution for your process. So this is just kind of an overview of the different families of zero point that we offer. Today, we're going to focus on the Stark Classic system. It's probably our most widely used product that we sell today, simply because it's very versatile, has a lot of options within it. But we have many other solutions, electromechanical. We have our balance system, which allows for float within the unit. Our connect systems, our AirTech systems, which are pneumatic and have that feedback, whether the unit is clamped or not clamped, as well as a fully double acting hydraulic system for those really high cycle applications. Well, as I said, today we're going to really focus on the Stark Classic system, which is a great fit for most applications. It is available in 3 sizes. It comes in either hydraulic or pneumatic. The way the system works, it is mechanically clamped and positively locked. So you only apply pressure to unclamp the system. So it is very safe from a power loss situation or really anything that could disrupt the system. It's not going to unclamp on its own. The hydraulic release can be accomplished via a pneumatic booster, i.e. an air over oil pump, but any hydraulic power unit can be used, whether it's electric or air over oil. One unique feature of this system is during release, the retention knob is actually lifted out of the fit for easier changeover and visual feedback. So when the unit unclamps, it actually contacts the bottom of the retention knob and pushes it up about 1 millimeter, which breaks that sealed surface and gives you a visual confirmation that the unit has been unclamped and makes it much easier to change. As I mentioned before, these are available with optional couplings for either hydraulic, air, vacuum, coolant blow off. Any of those things can be transferred through with automatic couplings. And we have the option in this series as well for blow off of the datum surfaces, as well as through the retention knob center for those automated scenarios where there's no operator visually verifying that everything's good. So what are the effects of a less holding force or a less rigid PowerPoint system? We all know in terms of cutting tools that a rigid setup is very important to reduce vibrations, harmonics, and increase quality. So with a less rigid system, you can have part movement, poor surface finish, difficulty holding tolerances. You can have tool service life issues from the vibration, uneven chip depth, forces at the cutting edge can cause fracture because of these things. Also, machine service life can be affected. If you have excessive vibrations in an unrigid setup, you can damage spindle bearings, linear guides and ways, etc. The reason that's important is because we really like to highlight with the Stark Classic system, especially the hydraulic option, we have a very rigid setup that actually has an active insertion force, always pulling down on the retention knob, not just locking. It's one of the defining unique points of our system. Many of our competitors offer a locking system where the retractable nipple is fixed in place and only fixed in place with sliders and balls. There's nothing physically pulling it down. Our system carries out active insertion into the planar support, which dampens oscillations and vibrations considerably, thereby increasing the quality of the workpiece and the service life of the tools used. So here's just a quick example of some of the testing we've done against our competitors, really highlighting what that active insertion force and that pull-in can do for you. So first, we're going to show a competitor product, and you can immediately see the amount of movement on that dial indicator. That's indicating the amount of vibration in the system. And you can see at the end how far we've moved from the actual 0 point. So that entire workpiece has shifted 10 microns. So then we move into an example showing the exact same setup, but our Stark Classic system. And immediately you can see the difference in how the vibration is attenuated due to that active insertion force and the rigidity. And once finished, we're right back at our 0 point. So we saw no actual movement of the part. So some of these differences, some of our competitors claim that their product can withstand a holding force of up to 40 kilonewtons, but that doesn't translate to maintaining positional accuracy up to 40 kilonewtons. So we've internally tested this with a number of different products as well as our own. And you can see on this chart, our advertised holding, our standard positional accuracy is 5 microns. And we maintain this accuracy up to 30 kilonewtons, surpassing that threshold before any movement of the retention knobs occurs. So that means that that full advertised holding force, we've maintained a solid connection to the face of the receiver and seen no movement. You can see with the blue line, one of our competitors, because they're simply locking laterally to the retention knob and not actually physically pulling it down, a very small amount of force shows they immediately start to move away from the 0 point. So while they may be able to hold the part from being completely removed at that advertised holding force, it does not translate to rigidity or accuracy. You can see that at 15% of their advertised holding force, they've already moved past 5 microns of position. We didn't test just one, we've tested many other systems, really to highlight that advantage that we have with the way our system functions with that active insertion force. Some of the other differences in our product really comes down to the details of the design. With our wear-proof insertion contours, provides pre-centering, prevents damage, and we use a high alloy corrosion-resistant steel, as well as stainless steel in some of the components. We have the matched radii between the clamping receiver and the retention knob, provides that pre-positioning. So it really just wants to line itself up and drop in. The fit is automatically aligned and drawn into position during the clamping action. So we're not relying on the operator putting it into place just right and getting it to drop down and then locking. We're actually setting it in place and using the active pull-in force to achieve that centering and lock everything into place where it needs to be. And with this design, it really enables us to prevent any chips being jammed into the cylindrical bore. High positioning accuracy with no bending or lifting. Again, that high active pulling force is effectively transferred from the retention knob to the OD of the receiver near the cap screws. The clamp position provides a positive lock between the receiver and the retention knob. Again, the lifting out of the fit. So during release of the retention knob, it's lifted out 1 millimeter. So the operator can visually see the system has been released, making for safe, easy, and straightforward handling. Design of our retention knobs allows for a high amount of angular misalignment during loading, as you can see in this video. We don't have to have it perfectly balanced and level. It's going to drop in. In this example, being a large pallet, we do have some pre-centering pins, but you can still see the amount of movement in that, the plane of that fixture, and that there was no obstruction as it drops into those retention knobs. This all makes for a very easy loading and unloading experience without having to worry about the pallet jamming if your angle's off a little bit. So we don't have any damage to the units or end up in a situation where we're clamping at an odd angle. Another key difference is the ease of cleaning and maintenance. So many of our competitors' products, you have to completely remove the unit from the base plate that it's installed in and disassemble it fully in order to clean the clamping points. Whereas with ours, the receiver can remain installed during cleaning, and it's simply a snap ring that retains keeps the retainer, the ball cage, and the lower seal. So it really makes it easy to maintain a clean system. You simply pull the snap ring out, pull the assembly out of the center, blow it out with air, and reinstall again in a matter of minutes. So we have many different retention knob options. Obviously, they come in the 0-point, diamond, and clearance or floating for your non-datum points. These can be installed in a variety of ways, whether through the retention knob itself, with a cap screw from the back side, or with a bushing to prevent damage to perhaps an aluminum pallet. But it makes for a very flexible system. We do have some standard systems available in a 4-fold or a 6-fold plate. We have surface mount kits available, as well as horizontal machining center tooling blocks. These would be standard catalog items geared towards most general applications. But one thing we really excel at is the custom and turnkey systems of a much larger scale. So to kind of recap what we've gone over so far in reference to the machining challenges we're addressing with 0-point, you can clearly see that with this system, you can nearly eliminate the time-consuming setup and changeover, the inconsistent clamping forces. We can mitigate safety risks, get a more efficient utilization of labor. We can add adaptability and flexibility to a machining center. So you could go from running a vise or 3 vices one day to running a dedicated fixture the next day to running a large billet of material with the retention knobs directly installed. And all of those setups could be accomplished in a matter of minutes and would be within 5 microns of the previous set point. So you in a high mix environment, you can really capitalize on keeping that spindle time up and not having scrap in those setups to try to get that first green sheet part. We can always be first part, good part, no matter when in the last time you ran that setup was. So from here, I'd like to jump into some of our 0-point applications to kind of give you some ideas of areas where this could be utilized. Maybe you'll see something similar to a process that you've encountered, or something you're currently trying to work with. As I mentioned before, turnkeys and these special applications or systems is where we really excel. First one I'm going to jump into here, we do a lot of aerospace. This in particular one was an aerospace structural component application. Some of the customers, pain points were increasing volumes, and they needed new machinery, and they wanted to equip those with a 0-point system to help overcome some of the previous challenges they had. So they had a lot of different parts and fixtures that needed to be ran through the same machine. And these are parts that were going to be ran over and over again, but in very low quantities due to order demands. So they needed that flexibility, they needed that quick changeover, and they also needed to make sure they weren't scrapping parts every time they set up. So some of the customers' unique requirements were a clamping system that would enable them to change the setup in less than 5 minutes. The clamping system needed to have the same pattern across all machines so they could run any given fixture and any machine that they had equipped. They wanted positional repeatability within 0.003 of an inch. They wanted to minimize the dimensions in the Z-axis to maximize the amount of machine travel they had, which that's something I hadn't quite mentioned yet, but you'll notice with a lot of our products, they have a very low Z height requirement in comparison to some of our competitors' products. So you can really minimize the amount of Z travel you're losing in a traditional machining center. They also required us to provide the installation, alignment, and maintenance training, which we did on site. So the first machine was a 5-axis vertical machining center. It was a large bridge mill. Kind of went through some initial concepts to accommodate some different size fixtures. As you can see, from a large fixture down to multiple smaller fixtures. And ultimately, this is the setup we kind of landed on. This was a complete set for the machine. We used some individual plates. These were all dialed in on site. So each set consisted of 6 3-fold plates with our Stark Classic 2 NG series. We provided all necessary hydraulic connections, all necessary mounting hardware. So this was a truly turnkey solution that we installed on site and helped with the runoffs. Same customer and the same project also had a trunnion style 5-axis machining center, and they had some really strict requirements on the amount of allowable deflection in the trunnion table itself. So rather than buy that from the machine builder, we supplied this as a turnkey all the way out to the cheek plates. So we designed the trunnion utilizing FEA to optimize the design to accommodate that deflection requirement. So we had a cast iron trunnion, roughly 142 inches in length. So this is a very large system using 12 of our classic NG2s. Again, we provided all necessary fastening and hardware. We also included our optical clamp control valve on this, which I'll speak to later. And we, again, installed this on site using shims to minimize deflection and really dial this into the machining center. And we were able to hit all the customer marks with a large margin. So another nice turnkey that we've done related to larger machining. This customer had low volume, high mix production parts, and they had very long setup times. In the next slide, you'll kind of see why. They needed to increase machine utilization to obviously get more parts through, but they needed to reduce those costs to be more competitive. They needed a very robust and rigid system. They had actually tried some competitor systems, and it just didn't meet their expectations or allow them the rigidity that they needed to have a good, robust process. But as you can see, again, a very large application. So we used our Classic 3 size. So it's a large boring mill, 25-ton table capacity. And you can see in that lower picture some very large castings that they're machining. So prior to a 0-point system, this was all set up using traditional T-slot, angle blocks, big right angle plates, toe clamps, and then having to kind of dial everything in. So, they were on average seeing about a 5-hour setup. So that's 5 hours the machine's not running. We all know that in a machine shop, your highest cost is time. Every minute that spindle isn't turning is costing you money. Because of this, they were only able to run during 2 shifts. So after implementing our 0-point system, both in the machine table itself, as well as the right angle plates, changeover was reduced from 5 hours to mere minutes. And that maximizing their utilization allowed them to actually run 3 full shifts now. So it's a very significant increase in throughput and a big cost reduction. Even though the initial investment would be high for a system like this, the payback is simply astronomical. Another good aerospace application at MTU Aero Engines in Munich Hall. So they had a new building. This was a complete new project. They wanted to automate the entire process. At 40 micron machines, they're using a Fastens pallet pool system with 2 or 3 setup stations that then go into a pallet pool to distribute to the machines. So, their parts go onto a fixture. It lives on that fixture through every process, and it's changed through every process via Stark 0-point. This is where we use the Classic 2 system in our high accuracy version. This is a special version that's manufactured to much higher tolerances, down to plus or minus 2.5 micron, and that's across all the machines. The twister also has that unique blowout feature through the center. So in a pallet pool scenario where the operator isn't having access to these systems, it ensures that there's never any chips or debris that could potentially get in the way. All these systems also included our clamp control valves, because some of these spin up to 3,000 RPMs. And this is all for aerospace components, be it rotors, blisks, etc. Here's a unique application kind of outside the machining realm. Again, aerospace. But this robotic drill drills holes down the length of an airplane fuselage, and the robot itself needs moved to multiple positions to achieve that length down the entire side of the plane. So we used our one of our pneumatic systems that has the integrated sensing. So allowed precision alignment at each station for the robot, provide feedback of clamped, unclamped, or not clamped correctly. And then we made a kind of a special gimbal system to accommodate for variations in the concrete flooring. Another Aero Engine application. This is with a great customer of ours, Rolls-Royce. A lot of these machines are using the Classic 3 system with the clamp control valve. And again, the special tolerance version to that less than 2 micron. These machines can load up to 1.6 tons of weight in the mill turns, and they spin at about 500 RPM. So they wanted a very safe system, which is why they went with our Classic. Again, because it's that mechanically clamped and hydraulically unclamped. So in a power loss or any situation, they're never going to lose clamping force. This project, we were able to reduce setup times by over 80%. The added rigidity of this system helped them to achieve a better quality part with less scrap. And again, it was a very safe system for them. Another great application with a pallet pool system here, showing another way that this can show cost savings. So typically in a pallet pool system like this, you've got to buy additional machine pallets from the machine tool builder themselves, which can add up to a lot of cost. Instead of doing that, since there were only 2 machines, we outfitted the machine tables that came with the machines with our 0-point system, and that conversion cost is roughly $70,000 for 2 machines. But then they were able to just put the retention knobs in the bottom of their fixtures rather than having the fixture and the machine pallet changed. So saved them a little over $400,000 in the 89 machine pallets that they would have had to purchase, and was an equally rigid and reliable setup. Another way to utilize zero point in a production flow environment is with adapter plates. So some of our customers have adopted the practice of creating a simple fixture that a part bolts to, like a cylinder head or an engine block. And in a production environment where you have many processes split up across multiple machines for process balance, or you have inspection or washing intermixed, outfitting your machines and all your secondary processes with the zero point, and then utilizing an adapter plate that every part is bolted to one, allows you to move that part from process to process without ever having to unclamp the part from the physical fixture. So we get that either 5 or 2 micron repeatability in the system, which ensures that from machines 1 through 20 and every inspection process thereafter, we are always maintaining that high degree of accuracy and never unclamping the part from the fixture itself. This is a cost-effective way to achieve this as well, and gives you a lot of access to parts like this, giving you 5 sides of access. It's going to also be integrated into the end of arm tooling or the grippers for transportation and things like that. Another great application here using direct workpiece clamping. This is using our Stark Balance system. Our Hydrotech system. So this is double acting hydraulic with no spring pack, and this is really designed for those million+ cycle applications where you don't want to worry about the life of a spring pack or maintenance intervals or things like that. So in a really high volume environment, think OEM automotive production of an engine block, there's hundreds of thousands of parts on an annual basis, sometimes millions. You want to ensure you have a good, robust process that has, no maintenance to disrupt that. So with the Hydrotech system on this application, we actually have a position flexible unit for that third point. This fixture was designed to accommodate 2 different sizes of block, a 4-cylinder and a 6-cylinder, without needing any actual changeover. So as you can see, there's kind of duplicate receivers there. One pattern is for the 4-cylinder, one pattern is for the 6-cylinder. So that fourth clamping position, as well as a Z-axis float. So it allows us to be able to clamp that part in its free state with no distortion, but have 4 extremely rigid mounting points. So here's a great example of our surface mount, how it can be utilized. And this isn't a machining application, but for fast changeover of a welding positioner, kind of highlight the flexibility of this system, and that it can be used in many, many different processes. Here we're able to give the customer a fast changeover, maximizing the welder uptime. And it was a simple modular installation with the surface mount plates. They simply bolt to a face that can be located with a dowel, or they can be dialed in, positionally with an indicator. It's a lighter weight than if they had gone with a fully integrated base plate. And it's standard components, so the very short implementation time that allows a simpler externally plumbed option. So this is a system that's great for retrofitting existing applications where you have some sort of interchangeable plate setup already, and you don't necessarily want to start from square one. This gives you the ability to, again, retrofit in a very diverse way. So kind of threw this in here at the end to talk about real quick. I mentioned some of these projects. We had the integrated safety valve. So for safety concerns, and we highly recommend this in any turning system, especially because it's a lot more dangerous. But anywhere where you want to verify via a visual feedback, or this could also be used to provide feedback to a controls to maybe even be integrated into the machine to not allow it to run in a case where it's not clamped. But it's a simple valve installed in the base plate below the unit. I got a short little video that kind of shows the basic operation. So you can see when the part's clamped, it closes the valve, provides that feedback. And we have that visual indicator, red or green, to give that operator the feedback that, hey, everything is good, it's safe to run, or it's safe to remove the pallet. So in a large machine application where you have a very heavy pallet, you want to make sure that you're not connecting the crane to it and removing the pallet prematurely, thereby damaging the machine. Integrating this into the system is just an additional safety measure to ensure that that never happens. So again, a quick recap here. Some of the pain points we've addressed via the setup time reduction, kind of eliminating those traditional methods of using bolts and clamps, or table keys or dowels. We're having to run a dial indicator and get things positioned just right. We're immediately in the machine, clamped up exactly where we need to be. Increasing that productivity by minimizing setup time, increasing that spindle uptime, giving it enhanced precision and repeatability, having that peace of mind that every time you put that fixture in, that vise in, if you're running a mold base and it comes back for rework, it goes right back in the machine and you're exactly where you need to be in relation to where it was machined the last time. Gives you that flexibility in production, whether you're running vices, fixtures, billets, etc. No matter what you're doing, you have the flexibility to change gears in an instant and not lose all that setup time. All this goes to optimizing your machine utilization, keeping those spindles on, keeping the lights on, keeping money flowing through. And that added benefit of reducing scrap and rework, because we got the peace of mind that we're getting a good part the first time, every time. We've got the enhanced rigidity, all those things working together to provide that overall great experience. So we got some user submitted questions here. I'm going to ask David to kind of chime in on these as well. So Andy F says, I'm interested in power work holding options for palletized workstations where leaving hydraulic lines in place is not possible. Yes, we absolutely have solutions for this, whether it's through the 0-point system or something out of our traditional power work holding catalog via either automatic or manual decoupling valves. Yes, we can accomplish this in a number of different ways. So Andy will reach out. I'd certainly like to know if you have a existing project you're working on, but we definitely have some resources to help you out here. Again, from Andy F, for repeating jobs, what do you recommend being the first steps to establish fixture life expectancy or preventative maintenance on them? So in the data sheets for, I believe, all of our products, we have established or recommended maintenance intervals. So that would be my first step. I would be, looking at the products that you've used in the system and, making a log of what our maintenance intervals are for that specific product, maybe comparing it to your expected throughput, and maybe proactively setting some dates where you expect to have hit that. And many of our maintenance intervals, I believe, are very conservative. So that maintenance interval is not a failure point. That is a good time to check things point. So with our 0 point, we have some tools that can help accomplish that to monitor, the clamping force. So at those given intervals, you can verify that your spring pack hasn't, lost any of its clamping force. You could visually check your seals, things like that. But again, all of our data sheets have that information in there specific to the product to determine what the ideal maintenance intervals should be. So at this point, we'll open it up for questions. If there's any additional questions, I believe Allison is monitoring the chat.
I am, and we haven't gotten any new questions in.
Well, that means one of two things. Either this was very informative and answered all your questions, or I'm a really boring presenter. So hopefully it's the prior and not the latter.
Hector says it was very informative.
Thank you, Hector. I appreciate the feedback.
We do have a question, which I'm not sure we know the answer to, but can your system be adapted for neon sign assembly?
Absolutely. That sounds like a good application for our Easy Click system. One of the benefits or big advantages of the Easy Click system is how it sounds, Easy Click. So there's no unclamp required in order to load the part. It is a pneumatic system, so it's lower holding force, really ideal for either very light machining or assembly applications. So you can have the retention knobs installed directly into your sign frame or whatever apparatus you're using to hold it for assembly. And the operator simply lines it up and it snaps in place. And then it just requires pneumatic pressure to then release. So you still get, a high degree of repeatable accuracy, and it can really streamline assembly processes, especially if you're going from station to station, things like that. So we'll certainly send a follow-up to see if you'd like to share some more information about your application, and maybe we could take a look at it and see where our product might fit in.
So Robert is asking on the 5-sided engine block that you showed, how is it clamped?
Well, let me jump back real quick. So that was the engine block, but I believe you're referring to this one here. In this application, that subplate, they're bolted together. So there's an initial operation for that part where maybe some locating features and some threaded holes are qualified, and then it is bolted to that fixture directly to the part, and it lives on that fixture through all the downstream processes. In the actual engine block application here, the retention knobs themselves are they're actually a custom retention knob made to different heights, and those are installed directly to the engine block. So again, first operation of qualifying that engine block, locating on your cast datums, you're going to machine essentially the 4 positions where the retention knobs would be installed. And then rather than having an adapter plate, we actually just have the retention knobs threaded directly into the workpiece there.
Robert, I'm going to unmute you in case you have a follow-up question. But maybe not. Robert says that's a good answer. Okay.
All right. Well, if there are no more questions at this time, I believe that wraps up our session on quick changeover. I do have one more slide after this, or maybe 2, just showing some kind of new products that we've either recently released or are on the horizon. things that we're excited about that aren't necessarily 0 point, but can be used with 0 point. So the first one we're going to talk about is our new vise, which is our UC vise. UC stands for Universal Clamping. This is really a vise geared towards 5-axis machining, allowing a high amount of versatility, as well as great part access. So one part, one vise, endless capabilities. It's concentric through not only the clamping stroke, but through the adjustment as well. Some of the competitor vices of a similar footprint actually have to be set up for each part size. So this vise, through its entire stroke, maintains concentricity, and it's very accurate. It's a modular vise, so rather than buying extended length bases, it's simply a spindle extension. And you'll notice in this image, you see 2 spindles. The lower spindle achieves our positioning, so you tighten that to bring it up to the part. Then the upper spindle is actually what we're achieving our clamping force with. One thing that does is creates a closed loop of forces through those 2 planes and eliminates any forces being transferred into the base plate of the vise itself. So traditional vices rely on a very heavy base plate to kind of soak up some of those forces that are being transmitted from the part through the jaw and the single spindle into the base itself. Even with a heavy base, at high clamping forces, you can still see some deflection that can transfer into the machine table itself. One area this is important in is in a mill turn machine, where you have very, very tightly toleranced and high precision bearings in the table itself to enable it to, achieve a turning operation. If you have deflection transmitted through the base of the vise into that table itself, it could put an uneven load on those bearings and could prematurely cause wear in a mill turn type machine. This vise has several other great features to it, such as our pull down force. We use a 2-piece jaw that actually creates a down force at the clamping lip, rather than most vices that you kind of get some of that jaw lift or squeeze out. Again, it's a very versatile vise. The way the jaws travel in with the part allows for great access in a 5-axis machining application where you really need to get the spindle up as close to the part as you can. This vise has, and really all of our vices, or most of them, on the bottom side of the vise, we have the mounting positions for our 0 point system. So rather than needing a adapter plate to interface with our 0 point, we can have the vise directly clamped into a 0 point system. And again, that holds true with, I believe, most of the vices in our portfolio. There are some riser options. There's a whole host of jaw options. This is a vise we're very excited about. If you have a need for something like this, would like a demo, please don't hesitate to reach out. We'd love to, throw a vise in your machine, let you make chips, and, really see the value in it. All right, next I'm going to talk about our quick ship. If any of you were in our webinar that we did, I believe it was last fall, we really talked about the basics of power work holding. We also mentioned our quick ship catalog there. So while we have 25,000 product solutions, our quick ship catalog really addresses the majority of average hydraulic fixturing power work holding applications. So if you're building fixtures for unique shaped parts, this catalog has pretty much everything you're going to need for 90% of applications. These are our best price products, very competitive in the market. And the best part is they are stocked Lewis. So when you need that quick turnaround, You want to guarantee that there's always backup parts on the shelf. Quick ship catalogs are a great place to go. David, do you have anything to add?
I do not, Chris. Well done. Thank you.
All right. Well, Allison, I will hand this back to you. And unless there's any additional questions.
I don't see any additional questions coming through. I did drop some links in the chat to the new Vice brochure, Quick Ship catalog, and our Ditch the Wrench webinar, which is a great work holding 101 kind of session. Please feel free to reach out if you have any more questions. I think everyone has gotten emails from me, but my email will also be in the recording email that you'll get on follow-up, and happy to pass that on to our team so they can answer them. Oh, it looks like I might have. Oh, you're welcome, Rick. So thank you everyone for joining us, and I hope we see you on our next webinar.
Thanks, guys.